Hello, geometors. We are going to look at one more section here in our Unit 7, right triangle trigonometry unit. And we are going to wrap up with what I'm calling Extension 2, Law of Cosines. So the last section, we talked about this other formula called Law of Sines. And so the major criteria, I guess, as to when we might want to use either of these extensions is that these are not right triangles. So law of sines can be used in some situations, but sometimes you don't have enough information on your triangle to be able to set up a proportion. So we do need a second method. So this is called Law of Cosines, and it really has the same underlying idea, is that this is useful when you don't have a right triangle. Because remember, cosine or sine or tangent can only be used in right triangles. So this law of sine looks a little intimidating, and I mentioned in the last section that I'm really skipping the, we're not determining in geometry when to use which one. Geometry is about introducing you to this and getting you to work through the calculations. Versus me just giving you a problem and you have to decide whether you should use law of sine or law of cosine. So I will tell you which one to use. Now, even though the equation looks a little intimidating, I think you'll find there's a pattern to it. So the reason there are 3 equations written out is each of them begins with A, B, or C. So I'm going to read through them, and then you might pick up on the pattern as I read through it. So the first equation we're going to take, actually let me back up. Going back to your picture, similar to law of sines, opposite angle A, we're going to call lowercase angle or lowercase letter A. Opposite angle B is lowercase b, and C is C. Now if you don't have a triangle that's named ABC, you always can change the name. Like for example, if you're given like DEF, because the formulas have A's and B's and C's in them, you could come through here and modify it like this, because the one thing that does have to stay consistent is whatever the angle in question is, the side across from it, we generally use the lowercase letter, and that's going to correspond to the equations. So feel free to change your picture, and then you can go back at the very end, and whatever you answer, you can fit back in with D, E, and F. Okay, so here are the equations. A squared equals B squared plus C squared, and that right there kind of sounds like Pythagorean theorem a little bit with A, B, and C. So A squared equals B squared plus C squared minus 2 times B times C times the cosine of angle A. Okay, the second one, B squared equals A squared plus C squared, and then it's a very similar pattern, minus 2 times A times C cosine of B, and the last one. So I want you to notice that in the first 3 parts, whatever letter this is on the left of the equal sign, on the right of the equal sign are the other 2 squares. So like C squared equals A squared plus B squared. And then the other thing is that the 2 that are being added together are also going to be the 2 sides that are multiplied here, okay? So like if you notice, you've got A and C, and then here's A times C. A squared plus B squared, and here's AB. Now, the letter here, the cosine of the angle is always, I guess I should do a different color, is always going to match the first letter. So like if you're doing B squared, the cosine of B goes at the end. If you're doing C squared, the cosine of C goes at the end. And what I like to think of is if I've already, like if I'm doing B squared equals, I've already used A and C and A and C again. Notice I haven't used the letter B yet, so I need to do the cosine of B. So I'm going to highly recommend you rewrite the equation that you're going to work with as step 1 every single time. Okay, so number 1 here, in triangle ABC, A is equal to 11, which is labeled, B is equal to 17, and C is equal to 19. Now, if those weren't labeled, I would have labeled A, B, and C. We want to find the measure of angle C. So in order to do this, I'm going to select the one that's going to help me find the measure of angle C. Now, if I use this one here, cosine of C, if I were to do an inverse cosine of C, remember that gives me the measure of angle C. So because I need to target C, I wanted to select the second or the third equation. I don't want to put cosine of, I don't want to pick the top one because if you think about these uppercase letters, these are angle measures. I don't know what angle A is. So I'm going to do the third one. So step one, let's rewrite it. C squared equals A squared plus B squared. And it's always minus 2 and then times these two letters, A, B, and then times, I like to put a dot. I don't think you have to. Or actually, let's do parentheses like I did above. Times cosine of angle C. So from here on out, we plug in and we calculate. All right, C is 19. 19 squared equals, where's A? A is 11. 11 squared, B is 17, plus 17 squared, minus 2 times A, which is 11, times B, which is 17, times cosine, and I don't know the angle, so that's my only variable, my only unknown. Okay, let's simplify some of this. So let's go ahead and do 19 squared. So 361. 11 squared is 121. 17 squared is 289. Now, I am going to go ahead and just multiply these three numbers together. So 2 times 11 times 17 is 374. So it's minus that number. And then I'm going to keep times the cosine of C. Okay? So I want you to kind of think about what you do when you simplify. My next simplification will be right here. So if I do 121 plus 289 is 410. So 361 equals 410 minus 374 times the cosine of C. Okay, so here's what I want you to think of. I want you to consider if I gave you this equation. Let's say I changed it to 361 equals 410 minus 374 times x. So what would be your next step here? Well, my next step would be to take away 410 from both sides. Okay, so that's exactly what's going on over here. Think of this temporarily as 374 times a variable. All right, so what I have to do next is I have to isolate, I'm trying to isolate cosine of C. So let's take away 410 from both sides. So 361 minus 410 is negative 49. So this is negative 374 times the cosine of C. Okay, so again, this is like, think of this as negative 374 times x. So I need to undo that multiplication. I'm going to divide both sides by the number being multiplied by cosine of C. Okay, so I've got negative 49 on my calculator still, divided by negative 374. Okay, so I have this pretty long decimal. So I'm going to initially show you one way to do this. I'm going to take it out to 4 spots. So I'm going to go ahead and do 0.1310 equals the cosine of C. And so when we get to this point, in order to find the measure of an angle, remember this is just some sort of a ratio of adjacent over hypotenuse. So if I do the inverse cosine of this decimal, the answer will be the measure of angle C. Okay, so I can do inverse cosine of 0.1310. And so it's about an 82.5 degree angle. So 82.5, and we'll just do nearest tenth. I don't think I say, yeah, I don't say. So nearest tenth, or I guess if you wanted to do 2 spots, you could do 0.47. And so that's going to be my degree measure. So let me show you one other trick that you might be able to use. And I think I might have mentioned this in the last section. This, the ANS button is pretty useful for something like this. Okay, so I am going to back up to when I did this division right here. So if I do the negative 49 divided by negative 374. So if I think about my next step, I know that I need to do the inverse cosine of this. So what I could do, there's one of 2 ways to do this. I could say inverse cosine, second, and then the negative key of the answer. So my calculator remembers that decimal, and there's that same number. If you take it out 4 digits, 4 decimal places, you're probably safe on any sort of rounding. But in order then, maybe I don't need to write that decimal out. I can just go straight to the answer. Or what I even could do is go back even further. Like I could do inverse cosine of this fraction if I wanted. Now, I probably will just not enter the negatives because I know a negative divided by a negative is a positive. So I could do 49 divided by 374. And there's the same answer. Okay? So there's, you might consider that, and I'll try to show that as I go through it. Okay, so it really just turns into a big solving an equation once we have the right equation written. Okay, let's move on to the next one. Okay, use the law of cosine to solve the right triangle, round decimal answers to the nearest tenth. All right, we are going to have to do multiple things here. So my first step, I'm going to label the across the way letters. So across from angle A, we're going to call 4 is going to be lowercase a. Across from B is 6, and across from C is lowercase c, which is 5. So I guess it doesn't matter like where we start here. So maybe we'll just start with angle A. So I am going to use the one where I take the cosine of angle A because I will do an inverse cosine at the end. Okay, so let's write the equation. So it's going to start as a squared equals b squared plus c squared. And then it's always minus 2 times the 2 letters you just wrote, BC. And then you're going to also multiply cosine of capital A of angle A. Okay, A is 4. So I'm going to do 4 squared equals 6 squared plus 5 squared minus 2 times 6 times 5 times cosine of A. Okay, so now I'm going to square some things. I'm also going to do a couple things at once. I'm going to go ahead and square these and add together at the same time. So I'm going to go ahead and I'm going to square 4. I'm going to square these and add, and then I'm going to consolidate that number. Okay, so 4 squared is 16. So then 6 squared plus 5 squared is 61. So I can skip a step there and just go ahead and do that. And then I have to do 2 times 6 times 5, which is 60, times cosine of A. Okay, so I need to isolate cosine of A. So my next step, oh, I don't know why I wrote 16 squared there. That's just 16. So my next step is to take away 61 from both sides. So 16 take away or minus 61 is negative 45 equals negative 60 cosine of A. So then I'm still isolating cosine of A. So divide both sides by negative 60. So there's my negative 45 divided by negative 60. So I've got 0.75 is equal to the cosine of A. And so we need to do the inverse cosine, oops, gosh, 0.75. And so here's where if I have that 0.75 already, I'm just going to go like this. I'm going to do second cosine, second, and then the ANS key is above the negative key. So it's a 41.4 degree angle. So measure of angle A is 41.4 degrees. Okay, so that is part 1. Now, I know if you want to write that on there, you can. So I will probably target either B or C next. So maybe I'll just go for B. So I'm going to need to redo this for B. So if I want angle B, I want the one that starts with B squared. I wanted angle A here, so I started with A squared. So I'm going to work with B squared equals, and then now you want A and C to come next. A squared plus C squared, and then minus 2 times these two letters, and then times cosine of angle B, so capital B. And then now we just recalculate here. So B is 6, A is 4 squared, plug in here, so C is 5, 2 times 4 times 5. And if you want to pause the video and try to keep going and then see if you match the answer, you might try that. Okay, 36, and then I'm going to go ahead and do 4 squared plus 5 squared. Okay, so both of these consolidate to 41, and then 2 times 4 times 5 is 40 times cosine of B. And then I need to move 41 over. So 36 minus 41 is negative 5. Okay, I need to undo this multiplication here. So let's divide off negative 40. So negative 5 divided by negative 40. So 0.125 is equal to cosine of B. And so I want to do the inverse cosine of that decimal. So I'm going to do the answer key again. So I'm just going to do inverse cosine and then second and then the negative key. So that gives me about an 82.8 degree angle. So measure of angle B is 82.8 degrees. All right, so if you have, let me add 82.8. So at this point, I just need one more angle. And I know triangles have a sum of have a sum of 180 degrees. So I don't need to redo another, law of cosines. Let's just do the subtraction here. So let's take our 180. Let's take out the 41.4 and then subtract the 82.8. So the final answer for measure of angle C is 55.8 degrees. Okay. And those are my 3 angles. All right. So yes, it's kind of a lengthy formula, but I think once you get in the middle of it, it's not too bad. And it just becomes solving an equation. Okay. I am going to, let's do example 3. Example 3 looks a little bit different. So one more example here. All right, use the diagram to find the straight distance between the zoo and the movie theater. All right, so actually let's make a triangle here, zoo to movie theater. And so I've actually got some stuff labeled. So it looks like 8 blocks is this, 86 is this angle. We've got 6. And that's it. So let's put maybe, well, I guess I'll start with an X. But here's what I would recommend. There's no letters on here. So let's actually do what I mentioned at the very beginning. Let's go ahead and label it A, B, and C. And so it doesn't really matter. If we label it different, our work might be a little different. So I'll maybe go A at school, B at movie theater, and C at zoo. So that means across from those, across from C is going to be lowercase c, across from A is lowercase a, and across from B is lowercase b. So So I guess now instead of x, I'm going to cross that out, we're solving for lowercase a. So I want the equation that starts with lowercase a. So let's write that out. We've got a squared equals, and you want the other two letters, b squared plus c squared, minus 2 times these same two letters, bc, and then times cosine of angle A. Okay, plug in. So I don't know lowercase a, so leave that as your variable, but we know everything else. B is 6, C is 8, minus 2 times 6 times 8 times cosine. Now I do know, oh, wait a minute. I don't know. Okay, wait a minute. I've got, okay, pause. Hold on. I think all we need to do is modify real quick. Let me back up. Okay, hold on a second. Oh, you know what? I misread my picture. Okay, scrap that whole idea. The only thing we need to change, I'm sorry, I misread this from the very beginning. 86 is right here. So the measure of angle A is 86 degrees. Okay, sorry about that. I was thinking 86 was in this zoo spot. Okay, so we actually do have what we need. So everything here is fine. 86 is what I need because I was pausing because I needed something on angle A. Okay, so if you think about this, this is a number, this is a number. These are all numbers, and isn't cosine of 86 simply a number? So you honestly can just enter this in your calculator if you want. Now, if you want to separate it out, you can. Actually, I'm going to separate it out first. Let me show you what I mean by that. So if we go through, and if I go ahead and do 6 squared plus 8 squared, I get 100. And then minus, if I do 2 times 6 times 8, I get 96. It's a little easier to see. These are all just numbers, okay? So I could just do 100 minus 96 times cosine of 86. It'll just consolidate into one number. And for that matter, if I back up, I could have from the very beginning, I could have just typed this in, 6 squared plus 8 squared minus 2 times 6 times 8 times cosine of 86. Okay, I get the same thing. So a squared equals 93.3033 or 34. But here's where that answer button will come in handy. I need to solve for squared. So I need to square root that. So I'm going to use the answer button instead of retyping this. So I'm going to say second square root, second answer. And so it took the square root of that whole decimal. So A is about, let's just round it to the nearest tenth, 9.7. I guess 9.7 blocks. Okay. So you might investigate that answer button because that's an awful nice button to have. Okay, that's law of cosine. So the big deal on law of cosine is just getting comfortable with the equation, and then it really sort of enhances your algebra skills. Okay, that's it for this lesson.